Assalamualaikum, Doctor. My name is Wan Fatia and my group members is Nick Azim and Umi Umaira. We are from Group 11 and we will present our mini project that is titled Smartphone Addiction and its Impact on Mental Health using Machine Learning Techniques. So first, next slide. Okay, so our presentation consists of 4 parts, which is problem, statement, algorithm and justification, results and discussion, and conclusion. So for problem statement, smartphone addiction has become increasingly common issue, especially among university students and young adults. So unlike normal smartphone usage, smartphone addiction refers to compulsive, uncontrolled usage that disrupts daily functioning, mental health, and academic performance. So research has shown that excessive smartphone usage is associated with anxiety, depression, insomnia, poor academic outcomes, and social isolation. However, identifying individuals who are at risk remains difficult. So, current assessment methods, which is traditional screening tools, usually use questionnaires. And these questionnaires are subjective because users may underestimate or overestimate their own behavior. So, therefore, there is currently no automated or system that can objectively classify addiction risk using behavioral information. So to solve this problem, we propose artificial neural network ANN capable of learning complex behavioral patterns and predicting smartphone addiction risk automatically. Okay. Okay. The ANN train the model that we use is using back propagation. We selected multi-layer perceptron. So the main reason is that smartphone addiction depends on multiple behavioral factors interacting together. So for example, two people may have similar screen time but different stress levels and sleep duration, leading to different addiction risks. So these relationships are highly nonlinear. Linear models cannot capture such complex interaction effectively. And ANN learns this nonlinear relationship automatically through hidden layers. So to improve learning stability and reduce overfitting, we incorporated batch normalization, dropout, L2 regularization, and the output layer uses a sigmoid activation function because this is a binary classification problem lah. Okay, so before training the ANN, the dataset obviously had to be pre-processed because machine learning models require numerical input. So first, all numerical variables such as age, screen time, gaming hours, sleep hours, and notification were standardized using standard scalar. This transformed the data so that each feature has a mean of 0 and standard deviation of 1. So this prevents the variable with larger numerical ranges from dominating the learning process. Next, stress level is an ordinal variable with 3 levels, which is low, medium, and high. Since these categories have an inherent order, we encoded them using ordinal encoding, assigning value of 0, 1, and 2. And gender is a nominal variable with no natural ordering. And therefore, we use one hot encoding to convert it into binary columns without introducing artificial relationship. Academic work impact is already a binary variable, so we map it directly to yes equals to 1, no equals to 0. And after pre-processing, we split the dataset using a stratified split into 72% training, 8% validation, 20% testing. We use this stratified splitting so that each subset maintain the same addicted to not addicted ratio as the original dataset. So this ensures fair model evaluation.
So, why did we choose this neural network, or we call it ANN for this? So basically, the smartphone addiction isn't just about one thing. It's a messy mix of your sleep, your stress level, and how much you're actually on your phone. because these things all affect each other in complicated ways. Because a simple yes or no rule wouldn't work, so we built our proposal to act a bit like a brain with layers, so that can help spot those hidden patterns. And we also have a little change. Our data has way more addicted user than not addicted ones. So we decide we didn't fix that, and the propose might just get lazy and gets addicted for everyone. Uh, and then we added a special weight to the data to make sure it paid equal attention to both sides, which makes our result way more honest and accurate. So after testing it out, the result were actually really impressive. And our ways of propose this is to correct about like 92% to 95 of the time, which is awesome for seeing if someone is heading toward risky habits. But uh, the number of the most proud of this ROC AUC score of 0.98. Basically, that's a like a fancy way of saying that our purpose is really good at telling the difference between healthy user and addicted one without getting confused. And importantly, we tune in the purpose to be extra careful about not missing anyone who might be struggling. And we also and because in the healthy app, it was much way better to be safe and flag someone who is fine than to miss someone who actually needs help. So this is actually very reliable because it doesn't overthink, and it is ready to like to be used properly.
So moving on to our system implementation, that we are developed a web application that called a smart guard, but using a streamlight to demonstrate the practical deployment to train our ANN deep model. So SmartGuard has three sections. This is the first model dashboard. This gives an overview of our ANN structure, which have three hidden layers with ReLU and SIG mode activation trained to 7,500 records that we use in dataset, and is also display our performance metrics, confusion metrics, or how the model was built in and evaluate. So the second tool is the addiction diagnose. This is the core interactive features where the users enter the 12 behavior inputs such as daily screen time, social media usage, sleep durations, stress level, and so on. And the system will output the real-time risk, a radar chart visualizing the usage profile and risk classification low, moderate, or high. And finally, the last base session is a project details, where the context is a research objective, a technology stack use team, and reference. So I'm gonna demonstrate our project where I'm gonna run the project through the VS Code here, which is right here. So at first, we have to copy this to run because I'm using the Python to open the Streamlight. But before running the app itself, you need to install the pip install requirement, which is for the Python machine learning, where it takes the data set from this code, and then after that, after running all that, just copy and paste where I just put how to run the text file here, where I here, and just copy here and just put here, and I will pop up the localhost. So this is the model dashboard that I was talking about just then, where it has a report model performance, where the accuracy is 85%, precision, and more on that. And this is the ANN architecture overview, where they have input layers, hidden 1, hidden 2, hidden 3, output, and loss. And this is the data set information that from the data set itself, where the not addicted is very low actually. So this is the model evaluation plots where this shows the confusion matrix and ROC curve, and this is the training story for it. So I'm gonna go to the next page, which is diagnose addiction, where we can put the age for what's in the data set. Let's say we choose 20 and we choose male, and itself is smartphone if I do academics, right? So I'm gonna take like 10, maybe 15, and social media 5, gaming 2, work 5, and then sleep is 5, right? Gonna do like this, and then we can diagnose it, and it says it's high risk detected, and it's also giving the personal recommended where the users can take this recommendation and do. Let's go to the next page where the project details, where it shows the project overview, research objective, and the reference itself. Okay, what we built is smartphone edition ANN classifier achieving to the 92 and 95 accuracy, to ROC which is 0.6 and 0.8 on the dataset, and AN justified a non-linear class dimension, features interaction in that addiction data, requires a deep network, and we developed a smart guard using Streamlight GUI, provide the accessible real-time risk assessment with color code, risk panel, and personalized digital while recommendation. What I just live just now, and is the future direction. Maybe we choose a multi-class severity, non-mild, moderate, and severe, and passive for smartphone API data collection and validation against clinic SAS scores. Okay, that's all from us, Group 11. Thank you very much.